Welcome to the new lessons. Basically, this is not really a new lessons. As you can see, that this the drawing part is the kinematic and the conservation of energy coming from the first semester of the physics. But however, what you've learned or what you taught will you have to use those information in order for you to be successful in the physics course. That's why we have to keep refreshing and refreshing. And from now on, I have a very good, high expectation from y'all. I'm gonna be making more videos as the semester goes. And at the same time, you guys will have to have a notebook that you will have to have notes taken down before coming to class. If not, you will get points deducted because your job is to be taking notes before you come to class. And when you do come to class, I expect you to ask me lots of questions. If you don't ask any question, which by all means that you did not do your job as part of your learning system. So let's get back to what we have to discuss from last semester. So as you can see, this drawing part right here that you see, you will see that we have point A and point E. Those are points of reference. And then you have the length. So as you can see that the length will be L for both different systems. Okay? So let's interpret what's going on actually in this diagram so that everyone should know that we are on the same page. I just want to make sure that we're on the same page before we move on, because unless otherwise you will be lost. So basically that guy right there at point A is holding a rope, even though it doesn't say it's a rope, but by now you should know how to recognize the picture. That's the rope. A man mass M is holding a rope and is jumping off the rope. So when he jumps, this is his path, and then once he reaches over here, he will grab onto the second object, and eventually him and the second object will land at point D. In this case, it could be in the water or it could be on the floor. We don't know what it means, but those are the system that we need to interpret. So a new question will be to ask, calculate the speed just before collisions. Tensions, that's Newton's law of motion. So basically you can see A and B, they are already on two different topics we covered from last semester. And over here, speed of the person and object after collision, that's momentum. That's the third one. And then D, which is horizontal displacement, which is kinematic, which is what we've learned earlier. So as you can see, that what you've learned earlier will be at the end, because that's how the system goes. It depends on your system. So let's go ahead and interpret what question A is looking for. So I'm just gonna ask you guys. I have to stand up over here so that you guys can see me better. And I need to give space. So A, calculate the speed just before collision. So you have to use conservation law of energy. So at point A, nothing is moving. So I'm just gonna go ahead and potential energy is equal to kinetic energy at that point M2. So basically, I'm just gonna go ahead and write it down. So mass M, potential energy with mgh. Okay, that's the formula for potential energy, which is mgh, which is mass times gravity times the height. And the height in this case is the length. Is equal to 1/2 mv squared. As you can see, that you have the same mass, so I cancel out. Okay, that will be g. And I'm going to replace my L of the height, which is the length, by L. And then I'm trying to get it up 2, so I multiply by 2. To calculate the velocity, I have to square root this. So these are the term or the equation that you need to be able to solve for the initial velocity just before collisions by using conservation of energy. So I'm just gonna go ahead and write it out. Conservations of energy. This is very likely that you're going to be seeing throughout this semester 4 or 5 different topics combined. A. So now go back to B, tensions. Just go ahead, when it asks for tension, you're going to have to understand what's going on in terms of Newton's law of motions. So this one right here, that's the rod. It's attached to only. So at that point before collisions, that's M1G. Those are that's the first force, right? The force pulling downward due to the gravity, which is M1G. Must be equal to the force of tension. So let's go ahead and apply second laws. Newton's law of motion, which is F equal ma. The sigma of the force, which is sum of the forces. So let's interpret in the picture right here, how many forces are acting up on mass 1? Only 2. So it's T minus mg is equal to ma. But then at this point in time, the object is no longer swinging. It's like it's no longer moving. So you have to get rid of that. So that would be 0. So T minus mg 1 m1 T equal to 0. So your tension would be equal to mg. That's how you figure out what the tension is. So the tension will be equal to the weight of m1 only at that point in time. So now let's get back. Okay, let's go ahead and rewrite this topic right here and put the name and the term combined. So that's conservation law of energy. So this is Newton's laws. Because first we use second law of motions, and then we figure out that the object itself is no longer moving at this with acceleration. Then it's the first law of motion. So now go ahead and get back to question C. So question C is the speed of the person just after collisions. So when I'm talking about collisions, so you're gonna have to go back to momentum. So I'm just gonna write out is momentum. So remember, Pi is equal to Pf. It's the initial, final, okay, of momentum. So P is actually equal to mv, but we have two different objects represented by mass 1 and mass 2. And mass 1 and mass 2, we have certain velocity. We're going to interpret that again. m1 v1 plus m2 v2. As you can see from the picture, it actually says that the person is actually holding on to the object. So at this point in time, that person right here is holding on to this. So when it lands in the water, they actually combine. So it's a person holding something. Maybe it could be maybe a father or mother rescuing a son or daughter, you know, on lover or whatever. So the mass should be combined. As you can see, obviously I'm combining mass right here. That would be final velocity. That's what we're looking for. So go ahead, let's interpret what the first one is and the second is. Okay, m1, of course I'm gonna rewrite it as m1, but initial velocity of m1 coming from there. So I'm gonna replace that one with square root 2gl. This one is plus 0 because m2 is actually at rest. m1 plus m2 velocity f. Okay, now let's get back to what we have to do to get rid of everything. So I'm trying to isolate the one by itself, so I'm going to divide both sides by that. So it's going to be m1 square root 2gl. That's the length, remember? It depends on how long the length the rope is. Divided by m1 plus m2. That's what you need to do. That's your final velocity right after collisions. So basically, for your multiple choice question, you will be seeing something like this. And okay, now I've understood, you know, why a lot of people are failing the test, because sometimes we practice using calculator way too much, because, you know, square root 2 is actually 1.4.1, whatever that is. But when you have 1.4.1, but then when you look at square root 2, that's not the answer you're looking for, then it gets confused. I understand that now. So, but what that means is that I'm going to have to train you how to be able to manipulate all those terms more and more, which means you're going to have more homework. But don't worry about the homework, will be just like what you see on this video, but with different numbers and with different versions of the exam. For this is to prepare you to pass the AP exam. Okay, now I'm just gonna go ahead and have to actually explain horizontal displacement on the left hand side of the board. So basically, I'm just gonna shift the camera a little bit so that you can see it better that way. So kinematics. So now let's interpret what's going on here. Now we have this person right here is holding that, right? This is the situation that you see right now. You know, actually it's gonna be landing over here. You know this delta y, which is L. Delta x is what you're looking for. You don't know, that's what you're solving for. The combined mass right here has that velocity. We've just calculated that. That's the final velocity of the combined. So you're gonna write it down. This is, I'm just gonna go ahead and label m1 plus m2 velocity, initial velocity. I'm just gonna write down initial velocity in the x direction is equal to the one we just calculated from collisions topic, which is m1 square 2gl divided by m1 plus m2. The whole term itself is actually a velocity in the x directions. So now, let's look, okay, I'm just gonna give you more space to figure out what equation we should be thinking of. Anyone remember any equations? I'm gonna give you 3 different equations that you should be really familiar with. One of them is this. Final velocity is equal to initial velocity plus 2g delta y. The other one is delta y is equal to initial velocity times t plus 1/2 g t squared. The other one is this. Final velocity is initial velocity plus g t. Okay, so these are 3 different equations that you will be able to solve for certain thing. In this case, we are looking for the horizontal displacement, which is the distance from here to here. But then, let's look at what x is. The x is interpretation from where it lands all the way to its original position, and that's why I'm actually not writing at the h, I'm actually writing it down from here. You know, over here is already L. So whatever the answer you have from delta x over here, you're gonna have to add to L in order for you to get the answer you're looking for. Okay, now let's get back to what we have to know. So you know the height. So basically, you know this, you know this. You can get rid of that equation because you know you don't know that. And then we don't know final velocity either. So if you were to be doing this one right here, you know the height, which is L. This one is becomes 0 because in the y direction there's no velocity. Then you can calculate time. So let's go ahead and first do first. It's a 2-step. Calculate time. So I'm just gonna use that equation right here. VOY t plus 1/2 gt squared, right? This term is 0. I'm just going to get rid of that. And the other y we have right here is interpretation as it is interpreted as L. And then we have 1/2 gt squared. I'm solving for t, so I'm rearranged everything. So those are my time. Those are the time it takes for these 2 combined objects to land at a certain displacement in the x directions. So now